Welcome.
Hello.
Hello.
Yeah, hello. This presentation is going to be very unusual, actually, because Alex and Erik developed a game to present to you. So who could imagine that for a game development conference? Yep. Okay. So, but my first question.
It's the subject, right?
Yeah, my first question would be like, what was the first game you created?
Well, I created. It was during my studies, and I did a little mashup between a rhythm game and Angry Birds, where you had to basically defend your castle on the beat of the music. So yeah, it was pretty interesting. It didn't really work out in the end, though.
No? Mine is a bit longer ago. It was I heard from the audience as well, a C64. I'm from that age, so I developed in BASIC a maze game that worked pretty okay, but yeah, after a few levels it kind of crashed. But yeah, that was the first experience I had with game development.
Sounds cool. Okay, so let's start the presentation. So the stage is yours, and I guess you can start.
Thank you.
All right.
Okay, let's grab our controller.
Yeah, because you give the presentation with controllers nowadays, right?
Indeed.
So we're going to talk about 5 game developer habits that bring software engineers to the next level, right?
Right. Yeah.
So yeah, who are we? Let's start with that. For starters, my name is Chatzizacharias. I'm half Greek, half Dutch. We're streaming from Utrecht in the Netherlands, by the way. Thank you. With a beautiful mustache that I do not have. And I studied games. I worked in some small mobile game developers. I did a lot of indie game projects, and at some point I decided, let's give software engineering a try, and then transitioned to full-on .NET developer, and now even a Java developer. And that's me.
Brings us to me, myself, and I. Next one, yeah. I'm Erik Pronk. My background is not in IT. I studied food technology. That's kind of different, but during that period, I switched to IT. That was around the millennium. So they had a lot of need for IT personnel, and yeah, that sounded like a fun thing to do. So I did that. Now I'm working at JDriven as a software engineer architect, and yeah, I love what I do, and I love to combine my passion for gaming and technology with it.
As you might have understood, I will be the game developer of the talk, and you're gonna be the software engineer.
I will be the software engineer.
Right? Okay, so this is where we'll be having our little adventure.
Yeah.
So yeah, I think we can go to our little ghost guide, the guide, maybe.
Yeah, our guide. He's going to guide us through what we're going to do today here.
And a good starting point is, as he's pointing out, is why do we want to give this talk?
Why do we want to give this talk?
So yeah, I mean, game development and software engineering are very related, right? They are very similar, but there are some key differences, habits, methodologies, you could say, that differentiate the two. And as having worked in game development and software engineering myself, there are some things that I really like about game development that are not necessarily happening a lot within software engineering. And well, vice versa.
Vice versa, yeah. We're gonna have two views on the subject, and yeah, we'll go from there. And I think we can have a nice conversation on what we can learn from game development and the other way around.
Yeah.
So let's go in.
Let's get started, right?
Yes. Let's move down the hallway.
The dungeon.
Yeah, the dungeon. We don't have an agenda. We have a walkthrough, of course, because this is a game.
A game fact.
A game fact. So we're going to do a scroll down the hallway of history around software development, but software engineering, but also on game development.
Really to highlight the differences and the similarities.
Yeah, the differences, similarities, and some highlights of the eras. And I'm going to play 5 mini games with you guys. The first one is on performance, a very important subject in both sides of the coin. Then we're going to talk about agility. What is agility, and what does agility mean for a game developer, and what does agility mean for a software engineer? Same about full stack. How do we look at full stack, and what is full stack for a game developer or for a software engineer? Then we're going to focus on requirements and what a puzzle it can be. Then we're going to play the 5th mini game, which is going to be a lot of fun.
More fun than that guy, hopefully.
Hopefully more fun than that guy, indeed. And we're going to close it out with a conclusion. But first, we're going to start at our history waterfall, right?
Yeah, our trip down memory lane. I mean, if you look at this talk and in the end you're like, okay, I don't agree with this, that's fine. But at least we have given you a couple of history pointers along the way, right?
At least you learned something. So let's move down the hallway. And of course, I will start from a software engineering perspective, because software engineering is somewhat older than game development. And for software engineering, the basis is in 1703 with a German mathematician, Gottfried Wilhelm Leibniz, who introduces the binary system. And that's the basis of what we're doing in software engineering, but also in game development, of course. A long leap to the future, but a thing that is very influential within software engineering is the invention of the Turing machine, which is actually a machine that is a decision box, and it's called the human in the machine, and it actually could solve all complex problems that are out there, and I think it still can. Great invention by Alan Turing, and influential on our within our software engineering perspective. Then moving on to programming languages. The first programming languages was Fortran. It's a mother of all languages, and it was introduced in 1957. It was widely used then. It's still used, but not as widely as.
If somebody still uses Fortran, feel free to throw it in the chat.
Yeah, indeed. We love to hear.
And 1 year later, the first game was created, which was by physicist William Higginbotham, which is also interesting. He also worked on the atomic bomb, so that is something I didn't know before.
Yeah, but it's not on the screen, right? It's a oscilloscope, right?
Yeah, exactly. And he made Pong, and every game developer knows Pong. I think almost every game developer at some point tried to recreate Pong himself.
Brings us to 1968, where the start of the internet is, which was DARPA, who created ARPANET. That was the furthest connection of networks over America, the globe within America. So it's the birth of the internet, which will be hugely influential further in time.
Yeah, and then 2 years later, Computer Space was released, and it was the first arcade game ever. Maybe somebody played it at the arcade back then in the audience. I didn't. Maybe you did.
No, even before my time.
Okay.
Even before my time.
But it was really the first arcade game you could play commercially, which is pretty cool.
Yeah, that's great. And in 1971, the first personal computer was sold, the Kenbach 1. It was sold in the United States. It was the first personal computer out there. Then in the days it would have cost $750, which would be like $4,500 now. So still the same price as a medium-priced MacBook nowadays.
Yeah, and with the rise of personal computers or personal consoles and stuff like that, then Pong was also released as an arcade game that people could play at home. And maybe people that watch the 70s show recognize this console because it is what they actually use there as well. And they broke and Kels had to fix it. It was a pretty cool episode. And then in 1978, Space Invaders is the first game to sell over 1 million copies.
Yeah, everybody knows Space Invaders, right?
Yeah, and it made the game industry a multi-million dollar industry, you could say.
It kind of lifted off games.
Well, yeah.
Moving on to 1979, the Seattle University began offering a master's degree, so we finally could have got our degree in computer engineering, and that started. The first one was in 1979. So, if there are any people out there who actually have a master's degree in computer engineering from Seattle University from 1979, huge kudos.
And what you see now is, while the software engineering world, where was offering master's degrees and things like that, becoming more and more mature, the game industry crashed.
Yeah.
And everybody knows, or a lot of people know about the industry crash in 1983, right? Where Atari had to throw ET game cartridges in a ditch and dig them because there were just way too many. Pretty cool documentaries about it.
Great documentary.
Yeah. And then a couple of years later, Nintendo decided, okay, let's make a console. Let's fix this issue. this crash. And 8-bit consoles are born with Famicom in Japan or the Nintendo in the West.
Yeah. Also, 1985, hugely influential also on the game development, but from a software engineering perspective, C++ was created by the Danish scientist Bjørn Stroup, but also Windows version 1.0 was released. So 1985, quite an influential year for software.
We still use C++, right? Especially in Unreal Engine.
Absolutely.
And in 87, quick leap to the 16-bit consoles with the Super Famicom or the Sega Drive, Sega Mega Drive. There we go. The Super Nintendo, things like that.
Yeah. For my part of the whole way, the World Wide Web was introduced by Tim Berners-Lee. And also HTTP and HTML were introduced and thrown into the world and are still hugely influential on the part of online software, but also online gaming, of course. And moving on 1991, Linux was created by Linus Torvald, still very widely used as backend servers for games or for software out there.
Yeah. And then in 1992, Virtua Race and Virtua Fighter were the first polygon-based games. So truly revolutionizing how game developers make games, basically, from sprite-based orthographic layering of sprites to truly 3D. And actually, Virtua Fighter is the first game I've ever played as well.
Okay.
Which is not what you see.
I know, not this one.
Not this one. And then 93, Doom.
Yeah. I remember.
But Doom was also kind of influential because it wasn't as known back then, but when they released the source code, we became quite know how much effect it had on the game industry with clever algorithms like the fast inverse square root and things like that.
Yeah, that's hugely influential.
Yeah.
1995 is, from my perspective, a really cool year because the introduction of Java on May 23rd, 1995, the first release of Java was done. Also, Ruby and JavaScript were released in that year. So, from software engineering perspective, software development, really cool period because the birth of Java has a huge influence on software out there.
Even though .NET and Java don't necessarily are the best buddies, you can't deny that they
have similarities.
Similarities, and .NET was influenced by Java for sure.
Yeah,
and it really brought programming to the masses, almost you could say.
Yeah, true.
Then in 1998, the Unreal Engine was created. We have some cool talks about that later, but it really revolutionized how the game industry thought about game engines because until this point it was game has game engine, then you can use this game engine maybe for a sequel, and that was it. And Unreal was really the first engine that actually licensed the engine away for use by other games.
Yeah, and it's hugely influential for us as well because creating this game from scratch with everything that we did.
But it is made in Unity, though.
It's the same principle.
Yes. And then late 90s, a lot of people might have a lot of nostalgia about this, is where online LAN multiplayer really became popularized.
Yeah, I know.
StarCraft, Unreal Tournament, Quake, Half-Life.
Unreal Tournament, a lot.
LAN parties, going to your friends, staying up all night, just playing games. Lovely
your
times.
Friends with a car full of hardware
exactly.
to play a LAN party. Yeah, great times. Brings us to the early 2000s. In 2001, the Agile Manifesto for software development was published and Scrum was born. So at the beginning of the whole way with a waterfall, but now we're more in an agile way of developing software. And in 2001 was the first release of the software Agile Manifesto.
Yeah.
Yes, brings me to the next one, the rise of big data. Big data became a thing, became something that we know, still know, and is playing a real big part in everything we do from a software perspective, day in, day out. So it's really influential.
Yeah, and the beginning of 2000s, we also had the current console wars that are still ongoing, kickoff. Nintendo, PlayStation were already, fighting for market share, and that is also when the Xbox was released, or when Microsoft decided that I want a little piece of this pie. I want to get into the game industry, with quite a lot of success, you could say. And then in late 2000s, mobile games start taking over the world thanks to iOS and Android. And I mean, by now, everybody, a lot of people know that, of course, mobile gaming is the biggest gaming market out there.
The biggest market out there. Yeah. Speaking of markets, also in the late 2000s and 10s, cloud computing begins to rise, but also the first Bitcoin transaction. I don't know if you remember it, but it was a transaction for a pizza for 10K in Bitcoin, which was actually $25 back in that day. But would have been 90 million today, or maybe 20 million in an hour, or 130 million within a.
It's a volatile coin.
So that's hugely influential.
Yeah, and you see it, of course, how it's splashed over to game development, because now there are so many NFT and crypto and blockchain games out there, and the metaverse. Don't forget about the metaverse, which all started in 2012, where Oculus Rift kick-started, and VR was brought to the consumer. And right now, the people are trying to commercialize VR and bring it truly to everybody, especially Meta.
From my side of the hallway, but also hugely influential, I think, within the gaming development, containerization. Docker was released in 2013 to the world of software engineering, and shortly after Kubernetes, in 2014 was released. But also the term microservices was defined by ThoughtWorks. Kubernetes was, of course, highly long ago used within Google, but from 2014 it was open sourced.
Yeah, and when it comes to microservices, I tried to find out, was it the game industry that did it first, or was the software industry that did it first? I couldn't really pinpoint it, but I believe that the microservice architecture kind of started within the game industry. But I might be biased.
Yeah, you're biased.
But having microservices and the rise to software as a service also brought the rise to games as a service. And people know this term by now. Every other game, every big AAA title tries to be a game as a service, where they offer a subscription or offer microtransactions and create a stable revenue stream.
Yeah, brings us to the last one for both of us on quantum computing. In 2016, IBM makes quantum computer available into the cloud, but also what we're looking at within software engineering right now and into the future. I think quantum computer is really going to make an impact on maximizing the things that we can do with our software capacity.
Yeah, and I can't wait to see what happens in the game industry with quantum computing. We have more raw power to draw from, because in the end, games always push the limits of the hardware.
Absolutely,
right?
Absolutely, as we see right now.
And that brings us indeed to the first point.
Yeah.
Okay, so this is our little haul. I think we can go to our first point, first habit we have, which is the performance-first mindset.
Let's start with this mini game. So let's go to our guide.
The guide.
Yeah, it's a great guide.
All right. So, software engineers, do you think they think about performance all the time?
They do think about performance, but do I think it's always top of our mind? No, because we tend to focus more on clean code and code principles, and we have libraries for example, Link, and we do not take into account that there might be another way to approach it when looking from a performance perspective.
Yeah. So the games I worked at. I heard the term allocation budget or polygon budget a lot of times, and I think that's something that resonates with people in the chat. But in the software projects I work for, I've never heard the term, you have an allocation budget, you have a memory budget, things like that.
No, we don't.
And as game developer, I've really learned to always think what every single line of code I'm writing does underwater and what the impact is. Is this on the hot path? Is this not on the hot path? Can I get away with this? Things like that. So to visualize that, we made a little mini game.
And we made it proof for less gamer than
we made it casual proof, so to say.
Now, what are we trying to visualize with this?
Yeah, so this is a Squid Game for the people that watch the game.
Yeah.
The show, sorry. And and there are good there are glass platforms which can break and which doesn't break. And if you look very closely, you can see exactly which is which.
And it's also with performance. If you look very closely and take every line into account, you can predict the performance upfront instead of checking it from
later.
Later.
Okay. So I'd say let's go to the other side. Let's hope we do. I do better than previous times, because
I hope you do better than me.
Yeah, I hope so as well, because I've been failing quite spectacularly.
Yeah, that's good.
Let's go.
I tend to make the jumps, but as we see here, I'm not.
All right, and then like this, I think, and then like this, maybe, like this,
yes.
like this, like this, like this. Okay, and
then, not bad from my side.
And this should be the end.
It is the end.
I've seen worse.
Okay.
Oh, let's see the results. Now I pray I actually did better.
Yeah, and what we're going to see? You see that.
Oh, I did a little bit better from the looks of it. Not much better.
Not much better.
Yeah. Not even good at my own game. Kind of sucks. The pain of a game developer when players start beating
out playing you.
Yeah, right, exactly. But this should give the idea that game developers really think about every single line they do, because they always want that 60 frames per second, right, or 30 frames per second when you really have to. When you work with less powerful hardware, and software engineers typically they just write the right code, and at some point stores are going to be pop up like, okay, fixed performance, or outside consultancy is going to be brought in to look at the performance profile, everything, and see, okay, this is where you can fix things, right?
Yeah, that's true. But also looking from the game perspective, if you lack a frame, it shows. Immediately.
Gamers are complainers.
Gamers also are complainers, but because they have high standards and they're used to having a seamless experience. But from a software engineering perspective, a transaction takes a microsecond longer. That's not that big a deal. It becomes a deal when a lot of transactions start falling behind and your database isn't consistent anymore. So those issues pop up later, and then indeed you get the stories. Okay, our performance is lacking, so we need to profile it and we need to look at it. But I think what, from a software engineering perspective, we can learn if we make certain decisions that we need to do it from a perspective as looking at more at what the code could benefit from performance side, and not only from looking at how the code is written for maintainability or for cleanness in code. So that's something that we can learn from.
And of course, always a trade-off. But from my experience, I've experienced that when you really think about every single line that you write and what the performance is of that line that you're writing, at some point you're gonna have performance bottlenecks. And when people ask, okay, how can we fix the performance? Because you already kind of thought about it, you can immediately go like, okay, this is there, the issue is there, this is how we can fix it.
Yeah, true, and we need profiling to do that.
Yes. Okay, let's go to the next one.
Yes.
To the portal.
Let's see if we can get back to the hallway. Yes, we can.
And now we're gonna be agile.
Yeah, let's be agile. See if I can make this jump. Yes, I can. All right.
So, I think 90% of all software and game projects
everything is agile, right?
Is agile.
Yeah. Yeah, we saw in the hallway. It's a very ancient process.
And Scrum is probably the most. If you use Scrum, just let us know in the chat. It would be pretty awesome. And or if you use Kanban, is also a pretty popular one. But what does agility mean? What is agility for a software engineer?
Agility in software engineering is that you have your requirements. Together with the team, you define what you're going to do within a sprint. You try to minimize risks there. You try to be as predictable as possible to get the value for money. Let's put it like that. You want to be predictable, and you want to the customer wants certain features in a certain time frame, and you want to deliver that. So we have a process and methodologies in place to guide you through that.
It also sounds a little bit waterfallish, what you're telling me right now.
Yeah, no. That isn't true.
Okay, so we have a game development sprint and we have a software engineering sprint. And what you typically see, or at least what our experience is, also because software engineering is just more mature, right?
We have more years under our belt. So what you see in these two hallways is that are both sides of the hallways there are obstacles, but from a software perspective, the obstacles are more mitigated. There are well-defined stories. They are more predictable. You know where to go. You know what process to follow. You tend not to be. You don't want to be surprised.
Yeah, and in game development sprints, or at least the sprints I worked within games, if you have the following experience, let us know. You start working on a feature in a game, and then game designers have this crazy idea, and they come to you and say, "Okay, we're not going to do this anymore. We're going to do this instead." And then suddenly you have to stop everything you were doing, stop on your tracks, and just do something else.
Yeah, and that's from a software engineering perspective, that's not the way you want to work, because you want to be predictable. You want to, that was a hot one. You want to know what you're going to deliver. So you want to work on the things that are the highest priority and provide the highest value.
Yeah, and it's almost like something sacred, the sprint within software engineering.
Yeah, it actually is. Yeah, it's a holy ritual.
Yeah, I've experienced a lot of times that people say, "Okay, no, we cannot do this today, or we cannot fix this bug today because
it's not in the sprint.
Yeah, we cannot change the scope of the sprint."
Yeah, and I think that's one thing that we want to address with this talk is, of course, these rituals are there because you can be more predictable. You can deliver the value for money that is very nice because. To be very honest, how many games are on budget?
Yeah, it fluctuates a bit. Let's say on budget and on time is
none.
So I wouldn't say none, but not a lot.
Not a lot. Yeah. So, but that's something that, from a software engineering perspective, that's more predictable, and to be more strict in the process helps to be more predictable. But there's also some downsides.
Yeah, it really, as a engineer myself, maybe I don't know if irritated is the correct word, but having to being able to just quickly react to something, I don't know, it makes work just more exciting or something, for me at least.
It also, of course, stimulates creativity.
Yeah.
To be not as predictable and have more things that bother you.
And because I'm always in the mindset, okay, maybe this is going to be not actually in the game, I try to create more generic constructs that I can reuse left and right.
Yeah.
So there's a little bit of a nice conditioning happening there.
Absolutely. So that's on agility, right?
That's on agility, and then I think we can go to full stack.
Yes, a great jump here. Yes.
Nice. You are getting better at this.
I actually am, yeah. And you're getting worse.
Yes. All right. So what's full stack for software engineering?
Full stack for software engineer. That's working on the front end, doing a bit of UX UI, but also working on the designing the screens. Creating a front-end framework on top of that, building the back-end, the connection between front-end and back-end, connecting to your database, having some knowledge of infrastructure. That's basically the definition of full-stack developer for software engineering.
Yeah, and in game, especially in smaller teams, when you have a team of 3-4, let's say, sure, you might have your modeler or you have your coder and your designer. But what you'll see is at some point there's going to be a mix match of everyone being able to do everything approximately. So where software engineers, you could say they're more T-shaped, right?
More T-shaped, yeah, correct.
You can see especially full stack game developers, people that really consider them as full stack, are very cone-shaped. They can do a lot of things, and there is of course something they excel at. So I would say, well, coding is probably my strong suit, but I can pick up Photoshop, I can pick up Blender, and do things like that.
So you can pick up Blender. Now you tell me.
I have to let you do something as well.
Yeah, that's true.
And it's invaluable to have approximate knowledge of a lot of things. If your 3D modeler has an issue, just being able to brainstorm with him is very valuable.
It also makes your team more diverse.
Yeah. So let's see what the full stack.
What are the treasures?
Yeah. So we're gonna look for some treasures and see what full stack is for
us both.
For the both. And probably we missed some things.
But
the front end.
We're by no means complete.
No. But we have the front end, and of course the game itself is of course the front end for in-game development.
Absolutely, and front-end facing websites. Yeah.
Or a console application. Are you gonna dare?
Yeah, I'm gonna dare try the jump. Yeah, okay, I feel. But nevertheless,
I'll open it instead.
Yeah, I feel safe.
And then we have UX UI.
Yeah. Of course, what I mentioned in the intro for full stack development. Of course, within full stack developer, from software engineering perspective, you interact with your users.
And but in games, I mean, it's invaluable to have a good user experience, right? If your user experience is not good, then you don't play
the game.
Yeah, exactly. All right, then we have graphics programming.
Yeah, no, not doing a lot of those.
No?
No, not.
Maybe if you work in blockchain stuff.
Yeah, if I work on the GPU.
Yeah, but in games, you have to do some graphics programming at some point if you want to have good performance. So compute shaders or shaders programming, things like that. Invaluable. Are you gonna dare this jump?
No. I'll let you do this jump.
And this is, I think, writing. There it is. Ooh, it's a bit dark from here because you're all the way over there.
Yeah, but it's
writing.
It's writing. So writing, yeah.
Story writing.
Story writing. Oh no, we have the documentation on the code. That's writing, but it's different writing, I think. So that's more capability for a game developer, I guess.
Technical documentation is important for sure.
Of course, but is it writing?
It's not writing a story, right? Come up with a story, writing dialogue, things like that.
No, it should be to the point.
Coming up with a beautiful name like Guy the Guide.
Yeah, that's something that we really work hard to create. So it brings us to the following treasure, and that is what's going to be backend development. Backend, yeah, of course, that's something in a software engineering perspective. Of course, all our applications have a backend application to fit the logic. But from a game perspective, for the game backend or the game engine.
Yeah, and it's vastly different. You have your services on the backend, or if you have a multiplayer game, you actually have a server that handles all the multiplayer. It's your backend. But you can also have backend code within your client that handles all kinds of logic.
True.
But yeah, of course, both really needed.
So what do we have here? Animations. Yeah, we do have a lot of front end, but not that much animation. And if I need an animation, I go on the web and find one.
You go to web components and get animation. Well, I mean, of course, did not make this animation myself. The Unity people might have already see that we're using the Cinti Unity packages. But yeah, animations are involved. You need some animation if you're making game overall. They don't have to be good. Look at Vampire Survivors, a very popular game nowadays, or a couple of weeks ago. But you need some form of animation.
Yeah, absolutely. That brings us to the next one. Texturing. Yeah, the wonderful world we're in.
What is the last time you textured something as a software engineer?
Yeah, I can't remember exactly.
Ever had to create a cool texture for your console application?
No, not really.
Yeah, I mean, in games you need to, especially 3D games, you need some texturing, right? In 2D games a bit less, of course, because you have your sprites, but it is kind of important to be able to at least know how it works, how UVs work and things like that.
Yeah, absolutely.
And then we have
infrastructure, yeah. I think both sides of the coins.
DevOps.
DevOps, yeah, of course.
Very popular term nowadays. and invaluable in both industries, I would say.
Absolutely.
Kubernetes, as we said, is things like that. And then we have, I think, your favorite.
3D modeling, yeah, that's definitely my favorite because it was something that I never did. And of course, you can imagine being a game developer, Alex created most of the game. But I created some 3D models that we're using within the game. Was really great doing that because it was something that was extremely out of my comfort zone, but something that I never did before, but was really rewarding that I finished it. And we'll be there in the requirements puzzle. You can see the result. And I was pretty satisfied with it.
Yeah, and I mean, 3D modeling is important. I mean, you need to understand how it works if you're a full stack game developer. And then finally, we have
the things that you never hear.
Audio, which we do not have here because
we're the audio, right?
We are the audio.
We're the audio.
There's wink, wink.
Oh, you're really going to do that again?
No. So as you can see, game developers, when talking about full stack, there's a lot of things that they need to be aware of.
Broader spectrum.
And of course, it's not necessarily better or worse than a software engineer that is specialized. But personally, I feel it's very nice to just have knowledge of those things because you can talk with people about them. When you step out of your comfort zone, you learn new things. You're like, oh, whoa, this is also possible. This is also a possibility. The way I was used to is not necessarily the best way, and that only happens when you step outside of your comfort zone, when you try new things.
Yeah, indeed. And like Alex said, it's not the one or the other is better, but it's just a different approach and you have different techniques. But being open-minded in using different technologies and being open to use that within a sprint, it makes it also very flexible if somebody's on holiday, for example.
For sure.
Let's move on?
Yeah, let's move on.
Yes, brings us back to the hallway.
Okay, and I think we have one
puzzle. Yes, the requirements puzzle.
Did you just step on my head?
I actually did, and this was, again, I was faster than you were.
That's cheating.
Yeah.
All right, so requirements, very important, right? Especially if you work Scrum or Kanban, you need to gather requirements.
Yeah, you need to gather requirements, you need to know what adds value to what you're building. You need to know what's high priority, what the user wants. So really important to have great requirements and know what the expectations are that needs to be delivered.
And in software engineering, it's a puzzle, of course.
Absolutely, it's a puzzle. But like we discussed earlier, the puzzle pieces, you know where it's going. You know what picture is going to be there. You know what could be the result. But there's still puzzle pieces. You just need to be aware and find the correct position of the pieces, and then you can solve that puzzle like we're doing right here in our requirements puzzle with the nice 3D model.
You could say that through using requirement engineers or information scientists, information gatherers, software engineers actually have the whole requirements thing solved, maybe even.
Never solved fully, but it's solved more, and the process is more clear than from a gaming perspective, as we're going to see in a little bit. Because we tend to see where the puzzle is going, and we just need 3 more pieces. And
I wonder if people know already what this is.
I bet everybody knows what this is. It's one of my favorite Netflix series. Finished this year, I think, the last season. So. Casa de Papel, a nice 3D model.
Very nice.
So, right?
Very nice puzzle, yeah. And then we go in the game development.
That also is a puzzle, right?
Yeah, it's a huge puzzle because it's, the first thing that you want to do is make something fun. Your game has to be fun.
What's fun?
But what is fun, right? How do you define fun? I mean, can you define fun? It's something so extremely subjective. So then you start iterating, you start creating, you start making things, and before you know it, you end up with something completely different than what you had first in mind. You might start thinking, okay, I'm going to make this super cool first-person shooter, and in the end, you'll end up with, I don't know, maybe a third-person hack and slash game.
Yeah, indeed. It's much more complex to define things that are not measurable that easily.
Yeah, exactly. And that makes this whole puzzle very complicated, because you can't just hire a requirements engineer to that he's going to talk to people and gather the requirements for you. You have to come up with the requirements on the fly.
Yeah, true.
And you have to actually, maybe scrap user stories because they don't work anymore. It's like, you want to speed it up?
Yeah, that's because the puzzle is not.
It's going to take some time.
Yeah.
So this is my favorite movie. Not to be confused with the show that. No. It was a decent show. Let's keep it at that. But so my experience with this is that I've become. It really a user story that is not so insanely clearly defined as it is a lot of times within software engineering. Really leaves a little bit open for creativity for me as a developer. I can see, okay, implement double jump. You start with the double jump, you implement it, you're like, okay, this works, this is okay. And then before you know it, you end up with a gravity flipping button because that just is more fun. And then you show to people, oh, that's a good idea, that works fun. Or, hey, here I made a double jump and a dash, things like that. Oh, that's fun, we can add this. And really stimulates my creativity as a developer. Yeah. Having a little bit of more wiggle room in the implementation details.
Yeah, and I think that's something from a software engineering perspective. We have procedures for a reason to be, like I said earlier, more predictive and be on budget and on time.
Yeah.
But that limits a bit of the creativity and the open mind that you can have in achieving better results.
Yeah.
Not saying that you throw everything overboard, but just leave a little bit of more room for yourself to, evolve and be more. Yeah,
and some people might think now, but in games it's very easy to be creative like that. But it's 100% possible in software engineering as well. Different kinds of implementations, different kinds of algorithms you can use, making things faster. Just being creative about what you do.
You can be creative in anything that you do.
Exactly. I mean, software engineering as game development are both very creative.
And brings us to the same topic actually, having some fun, because if you want to take something into account from this talk, is that having fun is something that is really important. Oh, are we going to lose the ball? No, right?
I got it.
Oh, you got it. Because creating this game as a presentation was also something that, was not really done before, and was new for us as well. But we embraced
very experimental.
We embraced all the challenges and had a lot of fun doing it. Like I said, creating Easter eggs is something that's also familiar from a gaming perspective, but it's not familiar at all from software engineering perspective. But I think every application should have an Easter egg, and it should also be maintained because it's something you're proud of. You have a lot of pride in that application.
Yeah. And just having fun while working is very important, right? If you create fun in a game, you need to be able to have fun. Otherwise,
if you can't have fun, then the game will not be fun as well.
How can you make fun if you can't have fun?
Yeah.
And then there are people like, okay, I'm working at a software for bank. How is it possible for me to do fun stuff there?
Always possible.
ASCII art is fun. I've had a lot of fun with some ASCII art or fun code comments, and people, oh no comments, the code has to be clean in software engineering. But it's just, it takes away the joy, some joy from software engineering.
No, indeed, which is a shame, and I should really encourage everybody to do that within the software engineering perspective. And it's very easy to have some fun in ASCII art, like Alex said, and just mind the performance.
Yes,
not every line of code you do.
Performance very fun.
You want to score?
Yeah, I do want to score, because the whole point is to prove that the game developer can make the game. There we go.
Okay, you score.
Thank you for letting me score.
Yes, So, but also in this game, we added a lot of fun elements, Easter eggs. Please write them down in the chat somewhere if you found them. They're favorite thing for me and from Alex. So.
Yeah. Some personality traits, you could say.
Yeah, indeed.
And I mean, personally, I've had a lot of chuckle from going through Git histories, Git comments, and finding comments from colleagues, funny comments, Easter eggs, things like that. And just brings a smile to my face, and it's important.
Makes the work this much more fun.
Yeah, and if you can't have fun at your work, then
then you shouldn't work. No, you should have fun everywhere you work.
Exactly. So I think we kind of are reaching
our conclusion. Epic steps.
The epic steps.
Yeah, we cannot run anymore, I think.
No, because that's dangerous.
It's dangerous on the stairs, so we created the fall safe. But as a conclusion, I think looking at the presentation we had and the things that we discussed, if you take one thing away, and that is having the fun factor in your work as a software engineer as well. Looking from it from a gaming perspective, of course there are things that the software engineering community and the software engineering and software engineer in general have more experience with and have more done over the years. So that's something that everybody can learn from. But from software engineering perspective, looking at game development, I think we can really incorporate some nice habits from the gaming perspective.
Yeah, I think so as well. And having done the switch myself some time ago, maybe some people will ask, why did you do the switch? But I'll answer that then. But I really miss, people just all screwing around with each other, in the code bases, living some fun Easter eggs, or, just game nights or game afternoons, so to say. Those are the things that really bring joy to work. And a happy developer is, I would say, typically a very productive developer.
Absolutely. So it brings us to the final stairs, right?
I think that does bring us to the final stairs. And again, there is no good or wrong. Both there's different maturity levels, of course. But in the end, those are some things that we believe could bring a lot of joy to a software engineer and really make his life easier as a software engineer.
Totally agree, but we have a game with no sound. That's not good, right?
No, no explosions.
No explosions.
There have to be explosions.
There has to be explosions.
And I hope this is not too, but as promised, explosions.
As promised, explosions. And like we said, we had a lot of fun creating these presentations. Just slightly different, like we said, than a normal presentation. But I think it captures what we want to highlight to you guys.
All right. Thank you very much.
Thank you very much. And to finish it off for Q&A, we have created a nice dance for you guys.
Completely with mocap and everything.
Yeah, we were in the green suits and we really had a lot of fun doing this. And you might recognize the dance. It's quite popular song from the 80s, but
before
leave
my
it in
time.
the chat. Yeah, it's before your time, but it's way my time. So,
mocap.
Yeah, mocap. We're open for questions.
Yeah, thank you very much.
About our volume here.
Yeah, I think that was really impressive, especially, the JetBrains logo in the end. I was personally really impressed. It was very epic. And you raised the bar really high for all our speakers. I don't know how they're going to proceed now.
Sorry.
Yeah, that was
I'm just going to say, hey, giggling at the dancing.
Yeah. We should start dancing maybe as well.
It's like a torn leg because we would have done it live.
Oh, yeah. And I have to say there were many great comments in the chat regarding the presentation itself and the format. I would just read a few so that you know that you're there. Like, it was cool how this game was made for this event, and so cool how this presentation is a game itself, and amazing to see how they have all these different game style, graphic styles in the presentation as well. And I have to say that I'm really impressed that you managed to talk and play at the same time. I find it really hard.
He's more.
For me, it was a little bit very natural being on Discord every night playing
Okay.
But for this guy,
yeah, that's why we created some fallbacks, right?
Yeah.
Because the original version I would have dropped in the lava like 300 times. So
as we said, very iterative process. So indeed, in the first versions, he died over and over again. And I was tell, okay, you just need to practice. You need to get better. But at some point, we had to just put on the fail-safe.
Yeah, you don't know that I'm not getting better.
How many hours did you practice before the talk?
Practice. That would be a lot of hours. I think if you're looking at the amount of time that put in it, I think more or less than 300-400 hours, I think.
Oh, wow.
Somewhere between 200, 400 hours, 300 hours. Yeah, something like that.
Great.
But it was fun.
It was fun.
You need to have a calorie count somewhere in the game for dancing. All right, folks, it was fun indeed, and I would like to reiterate, you've created the mark that every other speaker will need to top from now on. The only thing I would expect, the bare minimum, is making a game using your own engine written in your own language.
No.
That would be, amount of time.
Yeah, that would raise
drastically.
Maybe maybe next time, maybe next year.
All right, but speaking of engines, there was a question like, what engine was used to make this presentation?
Oh, Unity.
All right.
So we used Unity.
And now we know.
So let's get back to questions from the audience. The first one we'll start that is really close to my heart is, what are the IDE and software tools do you use for the development of video game applications?
So, me as a game developer, I use Unity. I started with Visual Studio, but I switched to Rider a couple of years ago. Which, it is easier for me.
What's Rider? What's that? Never heard about it.
Rider. Well, I would say Rider is the JetBrains IDE. But I also, for my day-to-day work as a software engineer, I typically use Rider or IntelliJ IDEA. It's very easy for me. And then for Blender, for the 3D modeling.
Yeah, I use Blender for the 3D modeling. Of course, as a version system, we use Git, which is not that easy within game development.
Yeah, it's not as easy as the software.
Yeah,
that's
from a software engineering perspective, it's much more intuitive and more predictable. From the game development, you have your limitations, and if you know them, you can work with it. But it's
for image, for sprites and textures and etc. I use or Photopea, the online Photoshop, or Paint.net, one of the two. And Audacity for audio. Very basic, very free.
The best of the world.
Exactly.
So the next question would be, what are the life cycle development process steps for developing a video game application?
Sorry, what are the?
Basically, what are the steps? What life cycle steps of game development?
Life cycle steps. I think it starts with a good storyline. That's, I think, the first.
Yeah, idea.
Storyline idea. You differ from the line, of course, but.
For me, it is first. I'm like, okay, you know what would be cool if you could do this and this. If you had a hack-and-slash game where you could rewind time, things like that, or. A truly rhythm hack and slash, and then you start from that and you refine your idea, and at some point you're gonna be like, okay, this core gameplay loop really fits. It is really fun, and so you focus on your core gameplay loop, and once that is done, when you're confident that it's fun, you start adding things like audio animation, 3D modeling, expanding the world, creating your levels, and things like that, until to a point where you think you are done. Which, I'll be honest, from a hobby project, has never happened before. There hasn't been a time where I was like, okay, I'm done.
So do you start with some sort of game mechanic and then build it up from there? Just kind of get something running and see how it goes, and then try and add on graphics and things?
Exactly.
When creating this game, we had a basic storyline, and that differed throughout the time, of course, but we worked from that, and let's do level by level, see what we want to achieve, what message we want to bring, and what can we do to bring that message. So that's basically how we did it.
Yeah, I really like the idea. I love the guide you had there as well. That's a great way of introducing stuff.
Thanks.
Great slides. Honestly, you've ruined me for presentations now.
Oh,
sorry.
That's great. And it big from me, from my personal experience in AAA game development, when there's so many people and so many money involved, and sometimes marketing, I don't know, costs much more than development, and you have a set date, you don't have that much space and time to reiterate an idea. So on the high scale, you basically have 3 steps, like pre-production, production, and polishing. So, and basically you try to put as much as idea as possible in pre-production, and in production, all I hear is feature cut, feature cut, feature cut. So, and by the end of the development, you got, I don't know, maybe 30% of the original idea that you had, because you don't have time to implement all those great ideas. Okay, so back to the questions from our lovely audience. Do you use any like popular add-ons while in the development? I guess if you use Unity a lot, so maybe some plugins for Unity.
The plugins for Unity I use a lot, almost always. I start a Unity project with DoTween, so it's a tweening engine. Always use it. First thing I install. And after that, the new Cinemachine plugins from Unity itself. I always try to use that for my camera right now. And recently I've migrated all my hobby projects to the new input system from Unity. It was released like a year ago. And that has been the standard for me as well. And those are basically the standard Unity plugins I always install for any project. Before I even know what I'm making, basically.
Do you make heavy use of the asset store and the plugins that are available there then?
Ooh, so much use. Yeah, especially art, as much as I can find. I've bought, I think, every single Humble bundle that has been with game development assets. I've bought it. So I just have a library I can draw from, right, when I need things. So these assets that you see here are also bought from one of those Humble bundles, for example. When it comes to for really technical plugins, I'm, let's say, a stupid one. I try to reinvent the wheel as much as possible. The one plugin I use extensively is animation plugins. So and state machine plugins, behavior tree sort.
Do you prefer to use the plugins there rather than rolling your own for that kind of thing?
It's just not my for my cup of tea, so to say. And inverse kinematics, I tried to make it myself a couple of times. Did not work as good, and then I was like, okay, maybe I should just use a plugin for this instead.
Mm-hmm. You can then just concentrate on the things you need to concentrate on.
Exactly.
Yeah.
So next question, pretty peculiar one. Do you know any norms like ISO or PGO and standards for developing a video game application? Before you answer, I would like to mention that there is a C++ standard committee WG21 that consists of a lot of game developers and who are trying to push as much as their knowledge and feature request into the C++ development, like standard library and language development from the standpoint of the game developers and their needs. All right, go on.
Oh, thank you for answering the question.
Oh, no. I mean, that's completely the C++ niche world and with a little bit of the game development. So yeah.
The question was if we know starting points communities to get into game development.
Not exactly, like standards like ISO standards or
ISO standards. Oh, sorry, yeah. Us Dutch is thinking ISO instead of ISO. Well, personally, no. I'll be honest, I never had the curiosity or anything to look up for such standards in game development.
No, not as I'm aware of. From a software engineer perspective, there, of course, are lots more standards out there. Yeah. Doing game development for this game, no, didn't pop up.
No. So, no, sorry.
All right. Oh, that's okay. Another question that hits really close to everyone's mind is how to switch careers from other industry to game development if you're a software engineer. What should be you focusing on?
That's a very tricky one, right? If you want to switch careers, I mean, I did it the other way around. I switched from game development to software engineering. If I were to switch back, so let's say hypothetically I want to go back into game development, I would probably start with hobbying a project seriously in the night, maybe cut down one day of work. And once I have a foundation where I really feel, hey, this is good, this can be something, then I would probably go and work full time on it. But as an indie, I don't think I would ever go work at a game studio again personally. I would very much just want to bring my own game out there. But you can always, I mean, there are game studios, big game studios. In the Netherlands, we have a studio called Nixus, which does a lot of ports, which is basically looking for traditional software engineers to help with the backend systems, with the porting systems, port pipelines, things like that. So that can be a gateway into the game industry. The more those kind of companies.
It's interesting you're talking about sort of software engineering and some of the software engineering disciplines and things. Coming from that world, unit testing, for example, is quite a big deal, sort of, especially with sort of some more of the enterprise type things. We've had a question on the chat asking about, do you unit test your games, and how? I guess
we had the discussion as well because indeed, unit testing is a thing, but it's really hard to test everything within your game. There are some options of unit testing game and behavior parts.
Unity also has a,
but not to the extent that we're used to within software engineering, because it's really widely adopted within software engineering. It's really mature. You can unit test at a really low level to a high level, and integration test, and you can automate everything. So you have a change somewhere in your code, and you know what it reflects in the entire application.
Yeah.
And it's a bit.
It's so tricky in games, right? How do you end-to-end, or how do you integration test a game? You have to check the state of your screen, basically. So personally, what I do is when I typically use Unity, which is .NET. So I have like a very detached core, basically a backend within the game, and that is what I unit test typically. And that is the logic manipulation that's happening there. But I never unit test user interaction, stuff like that. So if the user presses this, then this should happen, things like that. Because it's just so tricky. And Unity has tooling, but it's not very mature. But a very good example of this is Factorio. You can go on YouTube. If you go like YouTube Factorio unit tests, you're going to see that they have their own framework where they do something within the game, and their framework verifies that the screen has the pixels it's supposed to have, and then it flashes green or red, and then they do that super fast, and in the end you get like a breakdown how many red flashes there were and how many green flashes there were. So I mean, it is possible if you invest a lot of time in it.
Mm-hmm.
Yeah, I actually have to say that, the topic is quite great because probably that we do some surveys in the community, and especially in C++, every year I'm a little bit freaked out with the result when the people say like 30% of C++ developers don't use unit test. I'm like, oh, wow. And I mean, like, I was trying to validate what's going on. I asked them if they do use unit test, but without some specific framework. There's still like about 20% who do some unit testing, but somehow manually, maybe, or with some custom frameworks. But like 30% still every year, they don't do anything. And the percent is even higher in the game dev sector. So and especially like game dev, embedded, these are the areas where I do expect people, do some testing. And I hope they just do some different testing instead, and they just say no, but they finally do at least something. Otherwise, I'm really surprised with that.